Hello, my name is Nelson Lopez. I work as the zDevOps specialist for IBM. And in this demo, I'll show you how you can use Azure DevOps pipelines to build and deploy a Cobol application to zOS. In Azure, we have a couple of components when you define a project. My project is called Test. And in my test project, I have a repo, I have some pipelines, a build and a release, and I have an artifact repository to store the output of my build and pass it to the release phase. Let me take a quick look at my repo, and it's a simple application repo. It has some properties to do the build. It has some source code, one to do JC, to hold my JCL, another one to manage my source code. Here is a simple program. It just does a display with a particular time. Once a developer uses his IDE and clones this repo on his desktop, and they make a change and they commit it back to the Azure repo, it'll trigger the pipelines. The pipelines have been configured to trigger when there's a commit or a pull request. Here's an example pipeline that I created to do the build and to trigger it based on a Git action is simply just enable it through the front end here. My particular pipeline does a few things. One is it cleans up a work area on my zOS environment, my file system on USS. It does the clone of the repo that was just committed. It does a DBB build, an IBM dependency-based build. It does the compiles and links. If it's DB2, it'll produce DBRMs. If they're BMS maps for CICS, it creates the logical and physical maps that are needed for the application. At this step, I basically show the sysprints of the compiles. Here I'm packaging the output of the DBB process. All DBRMs and node modules are stored in a tar file and packaged. I then stage it to an agent staging area, and then I use Azure's publish plugin to take the staged tar file using Azure's universal package plugin. A universal package is just an open-ended container for anything that you need to store in Azure. From a release pipeline perspective, you pretty much define them as hierarchically two stages. One is you define the artifacts, where what's the data going into the pipeline. In this case, it's the artifact repository that I defined for this project. I call it the packages are called test packages. I'll show you some more details on that in a second. But once the build creates the package and stores it in the repository, it kicks off this release pipeline, and it basically fires off a set of jobs or a job with a set of steps on my development LPAR. And it looks just like the build pipeline. It's just a series of steps to clean the environment, uh, grab the artifact from Azure's repo, downloads it to the agent, and from the agent, I get to distribute it over to my zOS LPAR. I unpack the tar file and run a Groovy script to deploy the components. In this case, it's just one application, one program, and it's load modules to a PDS for testing. So that's the release pipeline, and the artifact repository is pretty straightforward. You define what Microsoft Azure calls a feed. Um, and they have the standard feeds for their product lines. But as I mentioned, I'm using this feed called a universal package, which is an open-ended type of feed, and it's perfect for zOS types of artifacts. The artifact feed that I created has a package that I called test package, and you could see that Azure will manage every time I do a build, it will version it and store it and give you some statistics on the individual packages. The release is configured to always grab the latest release, but you could release any prior um, versions of the application for, let's say, backout. If there's a problem when you release, you could just re-release the prior release, which is not easy to say. So let me give you a quick walkthrough from an actual developer's perspective. I like to use VS Code. I've cloned that repo that I just showed you on my desktop. Here's that program. I just want to make sure that I have the latest version of all the source to avoid any merge conflicts. So that looks good. Now let me make a change to my program. Let's just change the time and let's commit this. So now this is pending a push over to my Azure repo. So we'll go ahead and do that. And then I'll jump back into my repository. Right here. At this point, my build pipeline should have kicked off and it's build number 921. And here's that commit message, time 11 o'clock. So basically what's happening now is the pipeline has started cloning the repo to zOS, the USS file system, and proceeding with all the other tasks that I showed you before. Let me just make sure that I go into my program and yes, it was updated. There's that time that I just changed from my desktop's IDE. Let's go check the status of this particular build. It looks like it's almost done. Let's look at the sysprint, and here's the results of the compile on my mainframe, and it did pick up my change, which is good. The next step is to stage the artifacts that the build just created in a tar file and put it in my agent, and then run the plugin on the agent to grab the tar file and publish it to the Azure artifact repository. So that concludes the CI phase of the pipeline. Let's see if the release phase has started. I've been playing with manual release and automated release, and I do look like I'm pending a prior release. So let's take a quick look. So the pipeline for releasing is dependent on the creation of a package, and 921, I believe, was the right, yep, that was the latest one, 921. So that is the correct build for the release. So the package that was created at build 921 is now available, and it's queued to be deployed to my development environment. But right now it looks like I'm pending the prior release that I was testing. Let me go ahead and approve that to get it out of the way. Um, the subsequent releases won't happen until all prior releases are completed. So it was just pending my approval. And the idea there is that in a prior test I did, I created a package with build 920. It ran the development tasks onto my development box. And before it would go to the next stage, which would be a production or UAT or QA box, it was configured to have me say, yes, it's ready to go. In other words, I've tested it on that development environment. I like what the results are. Now I'm releasing it manually to the next stage. So now that I've done that to my prior build, let me go back to the current one and see what step it's in. And it's currently processing. Um, Basically, all the steps are done. Let me see if I could take a look at that. So we have basic steps, my cleanup of the working directories. I downloaded the package that we just created. The tar file is sitting on the agent. And from the agent, I have a script to copy it to my target development platform, my zOS box. And here is my Groovy script that I've created to unpack the tar file from build 921 and release it or copy over the load modules to my PDS. So let's go to my PDS on the mainframe and just make sure that, yeah, there goes my program. One other thing I want to check before I test it is what I've done in this particular version of my Groovy scripts is I'm capturing the commit hash key. In this case, it's 51B9, and I'm adding it as the SSI field in my modules. So I could be absolutely sure 51B9 is correct. That's actually the hash of the Git repo at the time that I did the build, and it makes for great traceability. I know that this particular load module was created from that source repo. So let me now test my program. And it's, again, a very simple program, and I want to do a display of the current time that I entered. And it should say, yes, 11 o'clock. So that was the change we made in our IDE, 11 o'clock. So from my IDE, all I had to do was make a change in commit, and in a few seconds, log on to my mainframe and do my testing, all through automation with Azure DevOps pipelines, the build pipeline and the release pipeline, and Azure's artifact repository. And that concludes this demo. Thank you.